Semua dapat dengar tak? All of you can hear me? Okay, so this first as example here, you're going to write a program that if R20 is equal to R21, then R22 is cleared. So you need to write the program according to this flowchart here. So as I stated in the previous video, okay, for this kind of question, you have two solutions. Okay, one if the condition is no, and the second one with if the condition is yes. Okay, so in this example, we are going to compare between two registers, that is R20 and R21. If R20 equal to R21, then what happen? Okay, if yes, you need to clear R22. If no, you exit the loops. Okay, you exit this if else statement loops. Okay, so if you have this kind of question, so I advise you to do the flow chart. Okay, kamu kena buat flow chart dulu, and then after that you can see clearly what you're going to do. What is the what you call branch that you are going to use? Okay, according to that flow chart. Okay, so for in this case here, okay, for this one, because you are going to see whether the R20 and R20 is equal or not, so in this example, okay, you can use either BREQ and BRNE. Okay, so we have two solutions, one with the BREQ instruction and the other one with a BRNE. Okay, for the BREQ, so this is your BREQ lah dekat sini. Okay, means that if R20 is equal to 21, then what happens is you clear R22. If not, okay, BRNE. Okay, so you can use either this one or the second one. Okay, then the solution will be different lah. If you opt to use the BREQ, then this is the solution lah. If you opt to use the BRNE, then the solution will be different. Okay, next for this one here, okay, you are going to write a program that if R20 is less than 20, sorry, if R20 is less than 21, then R22 is increases. Okay, so please, what you call it, correct this for chart here. This is R20 and R21. Okay, you're going to see whether it's R20 is smaller or bigger. Okay, so in this, what we call here example here, what instruction that we're going to use untuk this example? Which instruction that you're going to use? You have a lot of branch instruction. So which one is the best that you're going to use in this example? Yang mana kita nak pakai? Can you tell me what instruction that you're going to use? Okay, there are two instructions. One is BRSS, which is the BRSS stand for branch if same or higher, and the second one here is BRLO, branch if lower. Okay, you cannot use the BRGE and BRLT. Why? Why you cannot use this BRGE and BRLT? Kenapa? Kenapa tak boleh? Why you cannot use the BRGE and BRLT? Because the BRGE stand for branch if greater or equal, while BRLT is branch if less than. Similar to this one. Sama juga dengan kat atas ni. Tapi kenapa tak boleh guna? Okay, because the BRGE and BRLT are designed for the signed number. Okay, this one is for the signed number only. Okay, if you have an unsigned number, you need to use this one lah, BRSS and BRLO. If you if the value here is a signed number, then you can use the BRTE and BRLT. Okay, so you have two conditions. Okay, yes or no. Okay, for yes, if you're going to use this what we call here, this pass here. Okay, this pass jalan kat sini. So what instruction that you're going to use? So this one here, BRLO. If not, okay, this is BRSH. Okay, so if the BRSH, so this is the solution lah. If you're going to use the BR. Okay, so this one salah ni ya. This one not BRSH. So okay, betul. If BRSH, then it's no operation. If not, you need to increment R22. Okay, so the one that you going to select will the programming here will be different lah. Okay, if you opt for BRLO, then the programming will be different with the BRSH. Okay, what about this one ya? Macam mana yang ni? Okay, yang ni pun you are going to write a program that if R20 is greater and equal than R21, then increase R22. Okay, again, tolong tukarkan this one. This is R20. Is it equal or greater than R21? If yes, then increment R22. If no, okay, exit from that statement. Okay, so again, for this question here, example here, you can use either BRLT or BRSH. Okay, so this one is BRSH. Sorry, not BRLT, BRLO. Salah eh. So please, okay, BRLT for the sign number. Okay, so this is BRLO. Okay, contoh lah, if I opt to use the BRSH, what is my solution here? Okay, first you need to compare lah. Compare R20 with R22 by using the CPR21. Okay, don't put CPR21 R20. So this one is wrong lah. Kalau you put CPR21 with R20, this is wrong. Okay, because you want going to compare R20 dengan R21. Which is it R20 is bigger or smaller? Okay, and then once you compare, and then now you're going to use the BRSH. Okay, so BRSH. Okay, so you put lah this one here is bigger. Okay, so this is the label that you're going to jump. Okay, so let's you put the bigger down here. What happened when R20 greater than R21? So next you're going to increment R22. So increment R22, and then after that you exit from this statement. So we just put here jump here. Okay, this is for the bigger lah. Okay, what happened if, okay, this is when R20 is greater than R21. What happened when R20 is smaller than R21? What you going to put down here after the BRSH instruction? Apa yang kita nak kena tulis kat situ? Okay, because if R20 is greater than R21, then it will go to here. If not, what are you going to do kat situ? Okay, so you need to use the jump here, which is dia akan lompat ke sini. Okay, so this when you use the BRSH. This is when you use the BRLO. Okay, next we look at another examples. Okay, you are going to write a program that execute the instruction ADD 30 ADDR30 R31 9 times. Okay, you're going to execute this operation, which is R30 tambah dengan R31 berapa kali? 9 times. So, how to do that? Macam mana nak buat? What are you going to do? Okay, first, you need to initialize your counter register. Okay, so I tulis tempat lain lah. Okay, so this one here. Okay, sekejap ya. Share. Okay. So sekarang, okay, what you're going to do is, okay, you're going to R30 equal to R30 tambah dengan R31. How many times? You're going to do 9 times, 9 kali. Okay, so what you're going to do? Okay, first you need to initialize your counter register. Okay, what is your counter register? How many times your counter you need to initialize? Berapa kali? 9 kali. Okay, so 9 times. Okay, so your counter is 9. Okay, so what are you going to do? Okay, so first, okay, you need to initialize your counter so that your counter equal to 9. Let's lah, your counter here you assign to your R16. Okay, R16 become your counter. So how to initialize R16 so that it have 9? So by using the LDI R16 9. So what happened? So counter sama dengan 9. Okay, so after you initialize your counter, what you're going to do? Okay, so we need to do this operation. Okay, because you're going to add this number R30 with R31. Okay, we don't know what is the value inside of R30, R31, so no need to load number to this R30, R31 lah. Okay, so assume that the R30 and R31 already has value inside. So next what you're going to do is you just write ADD, okay, R30 R31. So what happen after you execute this instruction? So R30 equal to R30 plus with R31. Okay, next what are you going to do? After you add this number here, R30 with R31. Next, we need to decrease our counter. Okay, so next instruction is decrease your counter by using the DEC, decrement your counter. So R16. So now what happened is the R16 now become 8. Okay, once you decrement R16, then what you're going to do? Okay, you need to check lah whether the R16 equal to 0 or not by using what instruction? Is it BREQ or BRNE? Mana satu nak pakai? BREQ ataupun BRNE. Okay, so we're going to use the BRNE. Okay, we're going to check, is it R16 equal to 0? If yes, what happened? If not, okay, you do the addition. If yes, then you exit from this loop here. Okay, so BRNE, let's put ulang. Okay, so where I was going to put this ulang label here, kat mana saya nak letak? Is it dekat sini or kat sini? Okay, so we put at this ADD instruction. Okay, don't put at this instruction LDI, because if you put at this instruction LDI instruction, what happens is then your R16 no longer decreases to 8. So now you set back your R16 to 9, which is wrong lah. Salah lah kat situ ya. So we just put this one, this is ulang. Okay. And then what happens if R16 equal to 0? Okay, so you just put another instruction down here. It will exit this loop and you just put here jump here. Okay, so this is the solution for this. Okay, this exercise here. Okay, for this question. Where question? Which one's question? This one. Okay, next we are going to see another examples. Okay, this one. Okay, you're going to write a program that calculates the result of 9 plus 8 plus 7 plus ... plus 1. Okay, how to do that? Okay, so this is the question. You have number. Okay, write the program to do this equation. Okay, what are you going to do? Okay, first, okay, what we're going to do is we need to find out what is the difference between the first number with the second number and the second number with the third number. Okay, find the difference. Okay, so since this one, this is a 9, this is 8, so this is 1. 8 and 7, this is 1. So the difference between the first number and second number is 1. Okay, next. Okay, you need to initialize your first number kat sini. Okay, so initialize your first number. So first number sama dengan 9. Okay, next. What are you going to do? Okay, what about the summation of this equation? We'll put in what register? Okay, so you need to initialize lah. Okay, the summation, the hasil result of this summation here will be put to, let's say lah, I put to R20. Okay, and then my first number I load to my R21. Okay, what about what we call here the loops? How many loops that I going to do here? Berapa banyak loops? Okay, so since this one here, okay, you're going to add 9 plus 8 plus 7 plus 6 plus 1 and then until 0. So you just, okay, compare, is it your number here? Okay, this number, is it equal to 0? If equal to 0, then it will exit from the loop. If not, then you keep do the addition process. Okay, so here to write the program, first, okay, I need to load this number 9 here to R21. Okay, by using the LDI R21 with 9. Okay, so this is my first number. Okay, and then I need to initialize the result, okay, result register, okay, which is I put to the result to R20. Okay, so what you're going to do is I need to clear the R20. Okay, so that the initial value of my result here is 0. So what I'm going to do is I just use the SCLR R20. Okay, so this is my results. Okay, next. What are you going to do? Okay, so I just add lah. Okay, so just use the ADD R20 with R21. So what happened here? The first one is 0 plus 9 and put the result to R20. So equal to 9. Okay, next. I need to add with 8. Okay, the next number that the next number that I should add here is 8. So what I'm going to do is I need to decrease R21 so that my R21 become 8. So we using the DEC instruction R21. So what happened here? So sekarang ni R21 sama dengan 8. Okay. Once you decrease your R21, then what you going to do? Okay. You need to ulang lah. Tambah balik dekat sini. Okay. So by using what instruction here? Okay. By using the B, R, and E. Okay. If the R21 not equal to 0, so it will add this number here. If yes, it will exit from this loops. Okay, so decrease B, R, and E ulang. So diulang. Okay, this label ulang I put kat sini. Okay, so what happened here? Now R20 is 9. Okay, and then what happened is for the second loop. Okay, for the second round, what happened is R20 plus with R21. So 9 tambah dengan 8. So hasilnya is 17. Okay. Then I decrease again my R21 because the next value that I'm going to add is 7. So now it becomes 7. And since R21 is not equal to 0, and it will keep repeating until 1. Okay. When R21 equal to 0, then it will exit this loop. Okay. So I just put here jump here. Okay. Any question? Ada soalan tak? Okay, this is how you're going to do this kind of programming lah. Okay. So next we looks at another examples. Okay. Again, this one here you're going to write a program that calculate the result of 1 plus 3 plus 5 plus ... plus 27. Okay, yep. Angel asking that can we put NOP at the last? Okay, for this one, okay. If you don't want to use the here jump here, you can put NOP also. Correct. Okay. Either you use this one or this one. Tak kisah. Mana-mana pun boleh pakai. Okay, so now let's look at this what we call example. Okay, you're going to add 1 plus 3 plus 5 plus ... plus 27. Okay, and then write down the program. Okay. Okay, so I just put kat sini. Okay, so this is my equation. 1 plus 3 plus 5 plus ... until plus 27. Okay, so first is first. What are you going to do? Right, you need to find the difference lah between this number here, amongst this number. Okay, first number with second number with third number. Okay, what are the difference? 2. Okay, the difference between this first number and second is 2, while second and third also 2. Okay, and then, so what is the first number? Okay, the starting number here is 1. Okay, so this is your first number. And this is your last number. Okay, how many loops that you're going to use? Okay, you can figure out lah. You just put 1, 3, 5, and you count lah how many number that you're going, how many loop that you're going to do. Or instead of counting the loops number, okay, we can use a condition which is if, okay, x smaller than 28, so it will do the addition. Okay. If x greater or equal than 28, then what happen? So exit addition. Okay. You can use this condition here, ataupun you can count the counter. Okay. So either way, mana-mana yang kamu nak pakai. Okay, so in this question here, okay, the 27 is decimal, not hexadecimal. Okay, unless it put the dollar sign in front of the 27, then that one is belong to hexadecimal lah. So in this case, this is a decimal number. Okay, so now we're going to write down the program. Okay, first, load the first number. Okay, LDI R16 with 1. Okay, so this is your first number. Okay, next. What are you going to do? Okay, the second one here. Okay, next you need to initialize the register to put the result for this summation or this addition. Okay, so let's this one is R20. Okay, you put hasil tambah equation need to your R20. Okay, so I just clear my R20. Clear R20. So this is my R20 equal to my results. Okay, next. What are you going to do? Okay, then we add lah. Okay, so we add the number ADD R20 with R16. So what happened here? So R20 sama dengan, okay, the initial value of R20 is 0 lah, plus with 1. Okay, so dia akan sama dengan 1. So this is your first summation. Okay, next. Okay, the next addition, I need to add with 3. Betul tak? So what I'm going to do is, I need to increment this R16, how many times? 2 times, twice. Okay, so increment R16, increment R16. So what happened? So sekarang ni R16 equal 3. Okay, lepas tu nak buat apa pula? Once you the increment R16, now it become the second number here. What are you going to do? Okay, you need to add lah. Okay, to do this operation ADD R20 with R16. So how to jump from here to here? Macam mana nak buat? Okay, by using a loop. Okay, what type of loop that we're going to use? Okay, this one here. this loop here by using this condition. Okay, if X smaller than 28, okay, you draw lah you punya flowchart. Yes, R20 sama dengan R20 plus R16. If no, then what you going to do? Exit the loop. Okay, so yang ni dia akan pergi masuk sini lagi sekali. Okay, so now what you're going to do is, okay, we need to compare lah. This is X. X is our R16. Is it R16 smaller than 28? So what instruction that you're going to use here? Instruction apa yang kita nak pakai? Okay, you can use either CP or CPI. Okay, for the CP, okay, you need to load another register with this value. If you're going to use the CP, okay, make sure that you load another register with 28. Okay, if you use the CPI, compare with immediate, no need to load another register with 28. So I use the CPI. Okay, I'm going to compare R16 with 28. Okay, so I compare R16 and 28. So what is the instruction that I'm going to use here? Okay, you can use the BR. Okay, so this one, this is a BRLO and this is a BRSH. Okay, mana satu nak pakai ni? Which one that you're going to use? Is it BRLO or BRSH? Okay, we going to use the BRLO. Kenapa? Why BRLO? Because we going to add the number again. R20 dengan R18. Okay, so BRLO ulang. So, you just put ulang kat sini. Okay, so what happened here? Now, R20 is 1 and then you plus with 3 and the total up is 4 lah. So increment R16, now R16 become 5. Okay, and it will keep repeated until your R16 equal to 27 tambah 2, which is 29. Okay, when R16 equal to 29, so you compare R29 with 28, so this instruction here is no longer valid, then you exit from the loop. So just put here jump here. Okay, so any question? Okay, Josh asking that can we use the BREQ, which is you compare R16 with 27? Okay, because you compare between two numbers. If the two numbers are same, then what happens? So you will exit from the loop. I think that one cannot. Tak boleh. Why? Because if this one here, the R16, 27, and then if you use the BREQ kat sini, okay, since this is 27 compare with a 27, so what happens? So this one is true. Okay, it will, yes, it will miss the addition with this, the 27 here. So you cannot use the BREQ. Unless you compare R16 with 29, then you can use the BREQ. Okay, so next, let's look at this final exams. Okay, macam mana ni? Can I put? Okay, so I just delete this one. Okay. So by referring to this figure Q3 below, you are going to write the assembly language that will read 10 bytes of data one at a time. Okay, the data are located at memory address 200 until 209. Okay, once the data is read, the individual data is filtered. If the data is equal or greater than 0, then it is stored in the memory addresses starting from address 300. Okay, so please change this one to 300, not 301. Whereas if it is less than 0, then the data is stored at a memory address starting at 400. Okay, example data are given below. So this is the data. Okay, you have a random data that are stored at address 200 until 209. Okay, so this is the data that are stored inside of these addresses. Okay, now what you're going to do is you're going to compare either this data here, is it a positive number or negative number. Okay, because you're going to compare with 0 kat situ. Sama ada dia positif ataupun negatif. If negative number, okay, what happened? It will be, okay, this value here, okay, this value that you read from this memory address will be stored to this address starting from address 300. If the value is positive number, so you're going to store that value to this address starting from address 400. So how to do that? Macam mana nak buat? Any idea how to do this question? Okay, so first what you're going to do is you just draw your flowchart lah. Okay, so this is a start, and then you're going to read data. Okay, starting from address berapa tadi? 200 until 209. Okay. Then after you read that data, what you're going to do? Okay, you need to compare the value inside of this address. Is it greater than 0 or not? Okay. If yes, what happened? If no, what happened? Okay, if yes, okay, saya kena tengok balik semula. If the value is greater than 0, is greater and equal than 0, then you need to store at address 400. Okay, so simpan, store dekat 400. And then you need to increase the memory address lah. If no, then you're going to store dekat address 300. And then next, okay, you need to check back lah. Okay, you need to load back the data from this memory addresses. Okay, so from 200 to 209, how many data? Okay, yes, this one here, you just change. Okay, instead of 301, you starting at 300. Okay, this one here change to 301, 302, 3 until 304. Okay, because the question asks to store in address 300. So how to do this one? Macam mana nak buat? Okay, first thing first, we need to identify what instruction that we going to use here. Okay, you're going to compare this value here. Is it greater than 0 or lower than 0? What instruction that you're going to use? Okay, we are going to use the BRMI and BRPL. Okay, BRMI stand for. Okay, mana ya tadi? Saya punya ni tadi. Okay, I just show you. Alah, saya dah delete ya. Can I recall back? Okay. See, this BRMI. BRMI, okay, to check whether it's a negative number, and BRPL to check whether it is positive numbers. Okay, so we use the BRMI and BRPL. Sorry. Okay, so this one here, we just take the BRMI for the negative number, and this is a BRPL for the positive number. It says that sekejap. I read again the what we call here the question. If the data is equal or greater than 0 and is stored in memory address starting dekat address 300. Okay, so please change. Okay, salah eh. So this one here, tolong tukar. Okay, please change that for the positive number. Okay, because we're going to follow this figure here. If the value, the data is positive number, then you need to store at address 400 plus. If negative number, then you're going to store at address 300 plus. Okay, thank you, Kenneth Low. Okay, please change because we just going to follow this figure here. Kat sini figure kat sini. Sorry. Okay, so what you going to do? Macam mana nak buat ni? Okay, so first, okay, you need to know lah. Okay, how many data that you're going to read from this address 200 to address 209. Okay, berapa banyak data kat situ? How many data? Okay, 10 data. Okay, which is the end address tolak with starting address minus with 1. Okay, so you get 10 data that you're going to fetch or you're going to read from these addresses starting from 200 to 209. Okay, so what are you going to do? Macam mana kita nak buat? Okay, because this one here, okay, this question here, this involve the memory addresses. Okay, 200, 300, and 400. So in this case, why not we use the pointer register? Okay, because this question here involve of the memory addresses, so you are going to use the pointer register. Okay, so we just initialize that. Okay, X is going to load the address from 200, pointer register X for address 200, while pointer register Y, okay, to store a data at address 300, while pointer register Z is going to store a data at address 400. Okay, so first thing first, what you're going to do is you just include lah. Okay, you just include the standard empty2def.inc file by using the .include. Okay, and then m32def.inc. Okay, next. Okay, you need to initialize lah your pointer register so that this pointer register point to this address. Okay, all of these pointer register pointed to this address 200, 300, and 400 respectively. So how to do that? Okay, so load I, because X going to pointed dekat address 200, Y 300, starting at 300, and Z is starting at address 400. So you need to make sure lah. Okay, so this is a low and high. Okay, make sure that the pointer register pointed to this address here. Okay, so macam mana nak buat? So load I XL, because this is a low. Okay, with what value? 0 lah. Okay, because low, the value for X is 0. So what you just put the load I XL with 0, and then load I XH. What value here? 0x02. Okay, after you execute this instruction, what happens is X automatically point to address 200. Okay, next. Okay, initialize your pointer register Y. Okay, YL with 0, and then load I YH with 0x03. So automatically Y now point to address 300. And last but not least, initialize your pointer register Z so that your Z pointed to address 400. Load I ZL with 0 and load I ZH with 0x04. So now what happens is Z automatically point to address 400. Okay, so you dah initialize your pointer register X. So next, what you're going to do? Okay, so we need to read lah. Okay, the data from address 200. Okay, by using what instruction? Nak pakai instruction apa? To read a data from address 200. What instruction that you're going to use? Is it a LDS, LDI, or LD? Okay, let's lah. This one here. Okay, DX here you put dekat R17 lah. Okay. So you're going to compare R. Is it R17 greater than 0? Okay, so you need to load the value from address 200, put to your R17, and then after that you compare with 0. Is it equal to 0 or greater than 0? If not, store to 300. If yes, store to 400. So how to do that? Macam mana nak buat? Anyone? Okay, so before you load the value, okay, better we initialize our counter here, counter register. Okay, so this one I just initialize. This is my counter R20. So LDI R20 with 10. So this is my counter. Okay, because I'm going to read the data starting from 200 to 209. Means that I have 10 loops to read that data. Okay, next, I just use the LD. Okay, so LD, so this is R17, R17. Okay, so with X plus. Okay, means that I load the data from pointer register X to R17, and then my pointer register X is increased by 1. Okay, so starting is at 200 lah. Mula-mula kita load from 200, and then after that, it will pointed to 201. Okay, which is we going to read the second data. Okay, lepas tu nak buat apa? Once you download the value from this address, so what are you going to do? Okay, you're going to compare with 0. Okay, so you're going to compare with 0. So what instruction that I need to use? Instruction apa nak pakai ni? Come on guys. What instruction that I going to use? Anyone? How to compare R17 with 0? By using what instruction? Okay, we use the CPI instruction. CPI R17 with 0. Okay, so you can use lah either BRPL or BRMI. So in this case, I just use the BRPL. So BRPL, so go to positive. Okay, bila dia, if the R70 is greater than 0, then I know that there is a positive number, so it will go to my positive. Okay, so I put the positive down here. So what happens when it is a positive number? Apa yang kita nak buat? When this is a positive number, we're going to store that value to address 400. Okay, when the value is a positive number, then you're going to store the value at address 400. Okay, so ST, okay, store Z plus R17 because Z is pointed to address 400. Okay, store dekat 400 when it is a positive number. Okay, correct. BRPL. Okay, betul. Okay, next. Then, what are you going to do? Decrease lah. Decrease R16. Okay, I decrease the counter here. Then after that, okay, check whether my counter is it equal to 0 or not. If yes, then I exit the loop. If not, then I need to read back. Okay, read the data back from this addresses that pointed by pointer register X. Okay, so put the ulang kat sini lah. So this is your ulang. Kat situ. Okay, so what happened if, what we call here, if the value of R16 is smaller than N. Oh, sorry, is smaller than 0. What happened? Okay, so it will go to, it will store that value to address 300 lah. Okay, because the value is negative, so kita akan store that value to address 300. So we just put kat sini. Okay, bila dia negative number, you just put store Y plus with R17. And then decrement your R16. And then branch not equal. If your R16 not equal to 0, and you go to ulang lah. Okay. So what happened? Okay, contoh lah dekat sini. Okay, you suddenly run here. and then the R16 is 0. So what you're going to do? Okay, you need to jump done. Okay, which is the done you put below here. Okay, so this is your done. Okay, when the R16 equal to 0, so you just put jump done. Okay, if you not put this instruction here, kalau kamu tak tulis yang ni, what happen is, okay, once the R16 now become to 0, it will execute the next instruction, which is this instruction here, which is wrong lah, salah lah. Okay, so we need to put this. Okay, you need to put this jump done so that it will skip the positive, what we call it, the positive loop kat sini. So it will go down here. Okay, sorry. The counter should be R20. Yes, correct. The counter should be R20. Okay, not R16. Okay, so just okay, so tukar yang ni diterima R16 to R20. Okay, thank you. Anything? Okay, so I think we stop here. Okay, because actually I have another question, but I think this one here become your what we call here. Can this one become your assignment?
Sir,
Yeah.
I also want to ask why just now the question we cannot direct use the BRPL or BRMI instead of using the CPI first.
Mana ya? This one ya?
Yeah.
Okay. Okay. Kenapa kamu tak boleh guna use the BRPL, but you need to do the compare dulu? Is it?
Yeah.
Is that your question? Because
Yes.
if you use the BRPL, where the CPU going to compare that number? Okay. So before you use the branches, you need to compare that number dulu. Okay, so that the CPU know lah that number is it a positive number or negative number. If you don't write this one here, what happen is which number that you are going to compare kat sini? Betul tak?
Oh, okay.
Because the load here, if you use the LD here, the load, kalau kamu ingat balik, if you recall back, the load, every time you do the data movement, your status register will not affected. Okay, so dia tak boleh lah nak check.
Okay.
Which flag that are going to check here. So that's why we need to do the compare dulu. And then after that, followed by your branches.
Okay, thank you, sir.
Okay, welcome. Okay, so this is your assignment. Please submit after semester break. Boleh tak? Okay, you already screenshot this assignment? Okay, if no other question, then I think we stop here. Okay, after the semester break, we will continue with new chapter, which is step pointer. Okay, thank you, class. And have a nice semester break. Okay, for those who's not signed in, sign the attendance, please do so by scan this QR code here. Sekejap ya, I share back the QR code. Ini saya punya QR code tadi. Okay, Azrul, sekejap. I will give you the link to that WhatsApp groups. Sekejap ya, jangan keluar lagi. Okay, yang lain-lain boleh keluar lah. Okay, you can dismiss. Thank you, class. Sekejap ya, Azrul. Saya cari dulu. Okay, thank you guys.